Welcome to the first part of the Resident Evil puzzle tutorial. Now in this one we're going to be doing essentially the same thing that we did in the blueprint version of this series, but in C++. Now it's not going to be exclusively C++ because I believe working with widgets is much easier in Blueprint and it's designed to be used that way. This project is in Unreal Engine 5.7, in my case 7.4, and we're going to start by going to new project here. We're going to select our first person. We want to make sure we select C++ this time. And just so you're aware, we will be using the horror variant, but when you use C++, it automatically imports all the variants. So unlike Blueprint, where we would have to select it here, it already does it by itself. We'll call the project CPP for C++ underscore Resident Evil puzzle. That's a bit too long, so we'll just say RE puzzle instead. There we go. So create, wait for it. I'll get back to you once everything is loaded. Or while it's loading, in this part, this part is probably gonna be a bit shorter. We're just gonna cover generating all the C++ files we'll need, creating all the actors that are associated with it, and in the next part, we'll actually get into making all the different elements and doing the interaction first. I'd also like to add about this series that I'm making here. I am not an expert, or I don't consider myself an expert in C++. So do not take what I do here as best practices. If you yourself are more familiar with C++ and you see me make a mistake, please feel free to let me know in the comments and make sure other people don't make that same mistake. I won't be covering the basics like setting up a C++ project because you need to do some installs before with Visual Studio and stuff. But I will be going over the different paths that I use, at least to some extent, like I do in Blueprints as well. So it won't be a beginner-friendly tutorial, but I'll still try and explain everything I set up. Now that the project's loaded, you should have two things. You should have your Unreal Engine project that's open, but you should also have a C++ file open as well, which you can see here. And it should look more or less like this. Maybe your layout is slightly different, but if you're looking for it, it's just this extra panel to the side is just the Solution Explorer, which is essentially just the directory with all the files for the project. For some, I think by default it's on the right. So if ever you don't have this, you can find it in View, Solution Explorer, or Control plus W. If you don't have it, open it here, and it should appear on the screen. So back into Unreal. Before we go and compile the classes, we're actually going to import the assets as well first. So they will be down in the description, and there'll be a link to a Google Drive where you can get the assets there. First we're going to make a new folder here where we right click just so I have all the stuff at the same spot. So new folder, we'll call this puzzle. Inside of it, we're going to make a folder for our assets, and we're just going to have them all stored in the same place because there's only like 10 of them. So drag them in, and they should slowly start to appear. Yep. And this is for our FPX, our actual puzzle piece. Just leave it as is, import, and it should be fine. I think this does it. Let's Control-Shift-S to save it. Now what we're going to do is we are going to create all the classes that are going to populate our project, essentially. So all the blueprints. And the reason we're doing this immediately all in one go instead of as we usually would do it, which is progressively as we make the different parts of the project, we make the different actors, is because when you do C++ classes, you have to compile them. So it's easier to just have them all in one go because I know what the final result is. We can do that. So we're going to take that approach instead. So before we do that, because how Unreal works by default, every time you create a new class, it will compile. And that is annoying, that is long, and I don't want to pause the video every time to do that. So we're going to use a little trick that just makes it a bit easier. It's easier for you as well, you won't have to wait. It's in our editor preferences, so in top left, edit, editor preferences, wait for it to open up. Go to all settings and search for compile. And there are two settings here for live coding, first for live coding right here, you have automatically compile newly added C++ classes, which is usually what you want. I think actually a lot of people disable it by default. I don't have much of an issue with it because it doesn't cause any problems. It's just a slight bit slower. So we disable this so that when we compile, so that when we make 5 classes, it doesn't compile. We have to manually do it. So uncheck that, and I'm not sure if this one needs it as well, but we'll uncheck this one as well because it's also automatically compiling newly added C++ classes. So close this, and now what we're going to do is in tools, we're going to say new C++ class, and we're going to go and make, I believe, 7 or 8 of them. So let's get into them one by one. So first, new class, we are looking for actor. So here in all classes, we can also just select actor, just fine, it's the same thing. So next, now we're going to give it a name. We'll start with that, and we're going to call our new class RE_puzzle piece. So there are 2 ways you can actually set up a directory, so to speak, in a project. So either we can have them be public and private. So the header file would be private and the source file or the CBB file would be public. And so this is 2 separate folders inside your source folder of the project. You can also just have them be together in the same folder, and that's what we're going to do just because it's easier to manage and keep track of. Now, to make things more readable, because if we were to compile this here and create our class here, it would appear with everything else in this file right here. So it would be under this. Now, to keep things organized so we know which classes are ours that we made, we're going to make a folder like the variant shooter, but for our project. So we're going to open this up, and so here we're just going to call it we'll call it RE_puzzle. It's a bit redundant given the name here. We'll just call it tutorial. Oh, it's simple, easy to remember. And so if we create class now, we just wait for it to load. Now, while it's loading, you can actually open it up in Visual Studio and see it here. So this is the result, and it appears right now. It's not visible here in our solution because we haven't compiled it. Now, once it's done compiling in Unreal, it will say here, there we go, right there, that it's, notice the modification, do we want to reload? And so we're going to say reload all, and this is going to change. Now we have our tutorial, we have our puzzle piece CVP, and our puzzle piece header. Now, by default, we have some class functions that get set up based on the type here, which is what it inherited from, which is the A actor. Now, if you get some errors here, likely they're just going to take a second to load because there aren't any issues by default in most cases. Now, that's our first class out of the way. Now let's go through all the other ones. So open this up. Now, it has successfully created the class as we just saw. Do we want to edit the code? No, we don't need to. So we just press no, it will close it. If you press yes, it does the same thing. It just closes it if you haven't reloaded yet. So tools again, new C++ class, and we'll get the next one, which is going to be our puzzle door. So also an actor. So actor here, and we'll call this RE_puzzle door. Now, in case you don't remember which name you put here, you can also just open the folder and find it yourself, which ours is tutorial. So click on tutorial. It'll modify the directory here. So just to be sure, we are using an actor. Yes, if you go back and forth, it still remembers everything, so you don't need to worry about that. So we just create class. It will create now the second one. We're going to let it load. And now, once this is loaded, we're just going to repeat the process for 6 more, I think, and then we'll be done. I think this video is going to be rather short. We're just going to set up the classes and maybe set up the basis for our interact system, so our interface, but then we will cover that in the next part in more detail. So right now, you'll probably be seeing your Visual Studio light up saying something's happened. We can do our reload all again. For the next one, we'll just skip this step and we'll do it once all of them are ready. So back to Unreal, back to Tools, new C++ class. Also something you can note as well, you can also create C++ classes by going to all classes and going into the folder. Now, right now, because we haven't reloaded the editor, we don't actually have the tutorial folder, but you can also create a class here if you need. So tools, C++, because I still prefer to do it that way. And next we're going to make the controller. Now the controller isn't in here. Even if you can find the player controller like this, we don't want to use that. We want to use the horror controller, the one that already exists. So we're going to go to all classes. We're going to look for horror controller, layer controller. So this one, And as you can see, it inherits from the basic player controller. So next, we're going to go tutorial, I believe. Just double check. I'm pretty sure that's it. Yep, that's correct. If you don't have the backslash here, that's fine. It's not a problem. It still understands. We'll call this re_player controller. We will create class. You always have to wait for this to be done before being able to do anything else anyway. So we're just going to wait. That is another one down. No, we don't want to check the code. We're going to do another one. Tools, new C++ class. This time we're looking for a basic pawn. So select pawn. This is going to be re_header_pawn. Same thing as last time. Tutorial. Select create class. Now, one warning I will give when you're making these classes, be very careful not to go too quickly. If you get the wrong location, though, it can be a bit annoying due to the includes and how they work. So, just a heads up. So, don't try to rush this. Make sure you get the right classes correctly. Next, we're going to need a widget. So, we're going to look for all classes, user widget. This one right here. Next, same place, tutorial. And for the name, re_again, and we'll call this interact widget. Create the class. Next class, another widget, so user widget again. Select it here, next, and we're going to make the fade to black, so re fade to black widget. Select the tutorial folder again, create class. 2 more or 3 more left. The third one is a bit different. One more widget, so user widget again, not like that. Widget here, re_controls widget. Tutorial folder, create class. Okay, no. Now we have one more left before we actually get to our interface, because the interface is a little bit different. So we want to look for, this time, horror character. Make sure you choose this one. So next, we'll just call it character. And we'll select our tutorial folder. We will create class. So now we have the final one. Now the final one works like the other ones. We're still going to select one of the ones in here, but it's a less known one, I guess you could say. It's all the way at the bottom, and it's called Unreal Interface. How the interface works is a little bit different from normal classes, so we're going to get into that in a second. So select it, next, go into here, and we'll rename this to re_interact interface. So once again, same folder, tutorial, create the class, and once it's created, we have all our classes. We're going to quickly go through all of them, just a quick scan, just to check if everything is working. Normally, Visual Studio or whatever IDE you're using should generate the defaults by itself, but if they're not, you can see them then and make sure. So no, but we're going to go and click here manually and say reload all. So normally it should have all the different projects appear here, all the different folders, all the different classes. Now, normally by default, I believe it opens every single one of them here. So that's a lot because they all then appear down here as well. Usually, when you create a class, it will look like this, essentially. It will be class or uClass, or pretty much just saying it's an Unreal Engine class, not just a basic C++ class. Then we declare it's a new class, so essentially just a new blueprint, so to speak, if we're comparing it to the two. Then we say pretty much where it is. So this is just essentially saying that it is within the project file called re_puzzle_cpp, which is what we called it. And this is the name of our actual class that we just made. So the name of the blueprint, essentially. But there is an A in front of it because it is an actor, because it inherits all the way down the line back from the actor. And more recently, it inherited from the A horror character. So that's where we actually created it. Now, if we go back to to our first one, which was the puzzle piece, you'll notice that it has a few extra things. So all of them should have generated body. That is necessary. It is obligatory, or it is mandatory with Unreal. So it always should have generated body, or it can have some variants of it, but usually generated body is the most common one. It will have a constructor, which is essentially the same as the constructor in a blueprint in, well, blueprints, and it will be called before you actually, when you move an object, for instance, it gets called, I believe. And it's essentially used mainly for defaulting values in C++, rather than how you would use it in, for example, blueprints, where you would use it maybe for resizing an object. You probably wouldn't really use it here. You have another method for that, but I won't be covering that here at all. Then you have your begin play, which I'm sure everybody is familiar with if you've done blueprints before, and the same thing for tick. Now, there are obviously other functions you can find in here, because you can always inherit from the actor class here, for example. And if you're familiar with blueprints, you know there is also the begin overlap, there is also end play, and many others. And you can pretty much get them all by looking in your actor. I do believe we do need some as we go. So once we get to that point in the tutorial, I'll explain that there and then. Now, keep this in mind, how this looks. And now we're going to go to our interface, which is slightly or a bit different. So here we go. In the interface, you'll notice that you have actually two different classes. Now, Unreal pretty much makes it pretty clear this is unnecessary. You don't, well, it is necessary, you just do not need to modify it. So you never touch this part, you just need it to exist, essentially. And I believe it is just a matter of how interfaces are referenced and how they manage communication. So you need this second class for that. Now, essentially what that means is we're just going to make functions within our public thing, and it would work the exact same way as it does for a blueprint interface. So that's essentially what we're going to do here, and what we're going to cover for the rest of this video is just going to be creating those functions that we will be using later for the interact. So let's begin finally actually making some code, making some logic here. So we're going to start off by calling virtual voids begin overlap. Now, it's going to be a function. Essentially, this is how it works. If you're new to C++ and are not familiar with all these different terms, I'm going to explain probably the basics as I go, because I think some people might be coming over from the blueprint tutorial to here. Virtual isn't exclusive to interfaces. It can be used for any function, and it is from C++ itself. It's not Unreal exclusive. What it does is essentially lets your program or your game know that this function can be rewritten, because an interface by itself, as you're probably aware when you make a blueprint interface, doesn't have any logic. It's just an empty function that has parameters, and that is it. And so it needs to be changed elsewhere. And so the way you do that is you say virtual, meaning it can be overridden. It can be changed in a child actor that uses that interface. So same as how in Unreal you select your new interface in the default settings of your, let's say, your actor, and then some new functions appear in the interface section of your like variables, functions, and macros. That's pretty much overriding a virtual function. It's the same thing here. So we're getting a little error here because we don't have a definition for this function. Now, a definition can be done in a few ways. You can go here, you can say create a definition, but because this is an interface and we don't need any logic to have them by default, we can just add two curly brackets here to say that this is the definition. Now, it's going to take a second to realize that I've done this, but once it does, the error disappears because it realizes the begin overlap is this function. Now, this does it for a function. The virtual function for the interface, it's fine. Now, we do need to know what actor is overlapping, and so to do that, we're going to put a parameter. So this is like adding an input or an output. So for an input, we're going to say a actor, and we're going to put a star next to it to turn it into a pointer. And so what that means is that if we change anything on our variable here, it refers back to the actual variable in game. Now, in most cases, if you're talking about actors, components, and things that are actually in the scene, anything that is essentially derived from a U object, in most cases, is a pointer, because you're going to be wanting to talk to something that actually exists, that's been spawned in, so to speak. So That's why we have a star here. If we have, for instance, a float, it's just a float. Nothing more than that. So we're going to say, call this overlapped actor. There we go. So this does it for our begin overlap interface function. We're going to copy it and we're going to paste it below for end overlap. So we're just going to remove begin, call it end. And that does it for that. Now we're going to make another one. So we're going to copy it again. And this one is going to be our interact function. So we're going to call interact. Now it also uses an actor for what is interacting. So we'll call this, instead of overlap actor, the interactor. But we're going to need a second thing. And this isn't like our variable here. It's not a basic float either. We're going to need a Boolean, but we need the Boolean to be a return value. So there's two ways you can do a return value in C++. The first is to change our void here, which I forgot to mention completely earlier. Void means that there is no return value to your function. It means that it is a basic function that doesn't have any outputs. That's what void means. Now, if you want a singular output, you can replace the void by a Boolean, you can replace it by a float, you can replace it by anything you want, any type of variable. It could even be an actor. That works as well, obviously. Now, in our case, we're not going to do that. We're going to use the second method, which is to use the ampersand. So we're going to type Boolean, and before we type our name for our parameter, we're going to add the ampersand. So this right here, and we're going to say successful. And so what this does is essentially turns it into an output. And when you go through your program essentially here, let's say we were to call out interact. When we call interact, it needs two inputs. It's going to need an interactor and it's going to need a successful. Now, if this didn't have the and sign here, then we could just type in false or true as the input, and that would work. Now, because it is an and sign, meaning it's an output, unlike in blueprints, this means that the variable has to have an input first that can be changed within the function and then be used outside again. So it needs to essentially have a variable reference plugged into here. That's how it works. Now, if this function were to be put into blueprints, if we made it a U function essentially, which I think we'll look at later, then it would still just output like a normal pin and you wouldn't notice the difference. So you would, if for instance, let's say you had a function that you did in C++ that had two outputs, you would have to do this anyway. So it's better to do it here and learn, that way you know. Next function, virtual f vector. And we're going to call this get interaction location. And this one is going to output a f vector, meaning it's going to output a location. And so this time, because there's just one output and it doesn't have any inputs or anything complicated, we're just doing a normal f vector output. What we want to do is we're going to output pretty much this for the location of the object. So if it is not in 0, 0 of the relative location of the object, then we have to have a custom one, which we'll use right here. Now, unlike the other ones where our output is just this, if it's void, you don't need a return. In blueprints, you have, for instance, if you select a normal, let's say you make a function, if it has a return, an output, then you have to have that return node, and that return node has to be connected to the execution or it does not work. So the same thing applies here. If you have an output that isn't void, it needs to output something. So instead of just return, instead of just this empty thing, we need to have a return, which is like the return node, but we don't have anything, so we need an empty one. So the way you're making a empty vector is we'll say f vector, and we'll put parentheses, and that will create essentially a f vector that is null, that is empty. Now this is going to be overridden anyway, so it doesn't matter, but we still need to do this, otherwise the compiler won't like it. It'll be upset. So you also need to add curly brackets at the end. So normally if this were to be, let's say, a properly expanded function, it would look like this. So that's why you have to have the brackets at the end. Now it's just a bit simpler to organize and read like this, because this is not important. It's just empty outputs, it's empty values here. That's why they're all just like that. Now, for the final thing that we need for this function is we're going to add something called a const. And essentially a const isn't mandatory for what we're making. It doesn't change anything for how the code works or anything like that. It doesn't make the function any different. But what it does do is it is more efficient. So it's a good practice to have, to apply or to use. Now, what const does essentially is it tells the code, or the code that will run the code, that this function cannot change. Within it, anything that you do within this function remains in this function. So, for example, we cannot put that. For example, we cannot put const here because we're taking a variable, we're changing the variable within it, and then we're outputting that variable again. So that means something external is changing internally, so we cannot make it const. Now, if you do make it const and change something, it will give you a warning and it won't be able to compile. So you'll be aware of that pretty quickly. Now, in this case, we're only getting a value, so nothing's going to change. It's just going to return our vector, and that's it. So const, perfect, nothing changes. Finally, to finish, we have one last one, which is going to be virtual bool, and it's going to be ignore interaction. And same thing as what we just did with interaction location, it is going to be a const because it's just asking if we do ignore. If it's true, we do. If we don't, it's false. So we do curly brackets again, semicolon to end as usual. And because once again we have a return type, we need to have a return. And in this case, we don't need to do anything like this because we can just say that we return false. There we go. So this means if we do inherit this and we use this, by default it will return false. So it does. So that will do it for our interface class. Now we're going to stop here, and the reason we're going to do that is because the next part will involve applying this to the different parts, and that's going to take a lot of time as well as all the other stuff. Now, before we end, we can do one thing. We're going to go to our Unreal. We're going to close our Unreal, and we're going to reload the project. So the way we do that is very simple. For compiling your code and reopening the editor, there's a few things you want to know. So when you did some changes in C++, for those who are maybe a bit familiar with some terms in Unreal, there is the live coding and there is the compiling. So right now we have the project open in C++, but no editor. So that means there is no live coding because the live coding is the editor. Now, you cannot live code if you have modified a header file. Now, this is from experience, but maybe I'm sure there's a proper reason behind it, but I never learned it, but I learned from experience. If you change a header file and try to live code, it will cause errors. You'll be able to run your project, that'll work fine, but it will cause errors as you start playing. You'll get null references and stuff like that because there's some issues with the referencing once you live code after having made a change to the header. So you never want to do that there. Now, so in that case, if you change the header, meaning what we just did here, you may want to make sure you close your project first, and then you compile by saying Control F5, or the alternative is F5, and it will open it a bit slower and in a more debug mode, where if something goes wrong, it will show the actual line where something went wrong. We're just going to do a Control F5 to compile simply, and you want to make sure you have these settings similar to mine. Now, you want to have development editor, Win64 if you're in Windows 64. I think any other case might be a bit different, but you want development editor, Win64, CPP or the project file name, and you want to make sure you have skip compile. There are a few other options, but just skip compile does what it needs, but this is the most important one. You definitely don't want to have any of the other ones or it will not work. Otherwise, you'll start loading other things, whereas here it's specifically the project. So Control F5, and that will change the output here to say it's starting its build. And if you have any mistakes, it will let you know. It will make sure that you won't be able to compile unless you fix those issues. So you will be stuck with this until you solve those issues. Now, in this case, we didn't do much. We did very simple functions. As long as you have your curly brackets and you don't have any misinputs as far as names or letters go, you should be fine. So it might take a while to work because this is the first time we're compiling. So just give it a minute or two, maybe even 5. Get a coffee, get something, come back and it should be compiled. And if ever you're doubting if it's compiled, if ever you're in doubt if it is still working, just keep an eye here. It will tell you if it's failed. It will appear at the bottom here saying it is 1 succeeded or 0 succeeded, 1 failed, and X warnings. And if there is even 1 failed, and even if it succeeded but 1 failed, it will mean it didn't work, so you have to take a second to check why and go through it again. There we go. So as you can see, it took quite a bit of time, but build succeeded, 0 failed, 0 up to date, 0 skipped. So it's ready. Now you just give it a second for Unreal to pop up and it will start compiling here or loading. And once that's done, we should have our project and we can check if it worked correctly. There we go. The project file is now ready. So it's loaded. There we go. Now to check if this worked, if we open our C++ class again from all, C++ class, and our CPP, and our name of the project, we now have our tutorial folder with all the information we need. Now we can do a few things here. We can right click and we could create a new C++ class from it, or we can even create a blueprint, which is what we're going to be doing later. But this is just to show you that it does indeed work. We do have our logic appearing. I don't think we can do that for our interface because the interface is a little bit different. I don't actually think this will work, but I don't think we're going to click it just to check. So now that this is all here, we have all our classes, so we won't need to compile at least any more in the sense of making any more classes. A special thanks to everybody who's been supporting me on Patreon, and I hope you enjoyed the video. And for those who are new to C++ and was just coming from the blueprint version, I hope you can start to see how similar the two are and that it's not that much of a leap to actually go over to C++. So I hope to keep showing that with this tutorial. So I will see you in the next part. Goodbye.